Hello everyone, I'm Nika, I'm 13 years old, I'm founder of TAFU and your host for today. Thank you all for joining us. TAFU is a non-profit, non-protesting nature conservation organization. And our TAFU's goal is to show everyone their personal responsibility towards nature and how we should protect it using our common sense instead of continue destroying it. This presentation is about a common discussion in the world of nature conservation, and now in the recently in the everyday life, about geology and how important it is, but also its ups and downs and how we can make it better. So I'm going to introduce you to today's guests and participants. We've got my geology tutor, Dr. Greg Samways, who initiated the idea of me doing this presentation, and my paleontology tutor, Neil Ellis, whose camera just went off.
Yeah, I'm just trying to.
And he's been helping me. And then there's our 3 volunteers, Annie, Evan, and Aaron, and our guests, Julia, Simon, and Sean. So now I'm going to let you all introduce yourselves quickly, and then we'll start. So I guess, Annie, you can start first.
Thank you. My name's Annie. I am a legal administrator and I'm a volunteer for TAFU.
Okay. So, what about Greg?
Hi, I'm Greg. I'm a geologist for more than 30 years and a musician. And recently I've been teaching, helping Nika to learn about geology for her A-level.
Thank you. And Neil?
I think I'm unmuted now. Can you give me a thumbs up if you can hear me? Great. Yeah, I'm Neil. I'm assisting Greg with some of the A-level tuition in geology, with a particular focus on ancient life and its remains, so the fossil record and geological time in particular. So that makes a sort of double act with Greg, but I had a long career in nature conservation, working for a government advisor in nature conservation. So I have a strong interest in that too. Thanks.
Thank you. So, Ivan?
Hi, I'm Ivan. I'm a fresh marine biologist and I'm a TAFU volunteer.
Thank you. And Aaron?
Hi, Aaron, TAFU volunteer and the financial advisor.
Thank you. And Simon?
Yeah, hi everyone. My name's Simon. I'm a product manager. I have an interest in technology. I have an interest in technology on a personal side to do with climate change and the global environment. So I'm very interested to listen to what you've got to say to us, Nika.
Thank you. And Sean?
Unmute myself. Morning. Hello, everybody. Yeah, I'm Sean. My wife and I have been brought into geology by our children. It's a very interesting topic, so happy to be here today and to listen to the presentation. Thank you, Nika.
Thank you. And Julia's microphone and the camera aren't working very well today, so you're going to have to skip that one. Sorry about that. So yeah, I guess I'll just share my screen and we can start. 1 second. Oops. So, did you know that without geology, there wouldn't be any smartphones or laptops or TVs or almost anything really? Oops. Did you ever think about what's needed to make your phone? Really, it's a lot of elements. There are more than 90 elements in the periodic table, around 118, and 100 of them, approximately, are natural and the rest are artificial or man-made. And between 30 and 75 of them are in your phone, just depending on the brand. That's why there's such a big difference, and well, when it was made as well, because technology has been better now than it was before. Anyway, and there in the screen, the battery, the electronics, and the casing. So this means that there's an element in your phone from almost every geological process. Isn't that amazing? For example, there are rare earth elements from pegmatites and lithium from evaporating lakes, copper from hydrothermal and weathering, and gold from placer deposits. And lastly, there's nickel from ultramafic and mafic igneous rocks. So let's look at these in some more detail. First, let's look at lithium. Lithium forms from magma, which forms pegmatites. These pegmatites have spodumene and microminerals in them. These can be open cast mined, which causes a loss of habitat, traffic, and a lot of noise. Noise is often underestimated or undermined as a problem, but many animals, such as even us humans, depend on sound as a mode of communication. That sounds bad. And then without the possibility to use this mode of communication, or with it degraded, it's going to be really hard for animals to communicate. But anyway, these spodumene minerals, or the micas, can be dissolved and then go into lakes. These lakes can be evaporated, giving us the minerals we need. Or this water can go into groundwater, which can then be extracted, such as by Cornish Lithium. And we'll have a bit better look at Cornish Lithium a bit later. Now let's look at gold. Gold is made from metamorphic rocks, which make quartz veins. These quartz veins can either be directly mined, or which causes loss of habitat, or they could be weathered and eroded, transported, and finally accumulated, making placer deposits. These placer deposits can form on beaches and rivers, which are open cast mined, which again causes loss of habitat. I presume most of us know that there's a lot of gold in our phones, but did you know that there's enough gold to make all of the Olympic medals from just 6.2 million phones? I found that amazing. And there's also enough copper and silver in it to make all the phones. All the medals, I meant. Now let's look at REEs, or rare earth elements. Rare earth elements form from igneous and metamorphic rocks. They form accessory minerals, which are weathered, eroded, transported, and deposited. These form placer deposits, and these placer deposits can have garnets and diamonds in them. An example of an accessory mineral is monazite. Monazite has lanthanum in it, along with a lot of other rare earth elements. However, lanthanum is used in the phone, in the screen, as it says down here. Now let's look at copper. First, let's look at hydrothermal porphyry copper. This is formed from magma, which is partially melted. And then hot fluids rise from the top, and they're rich in metals. Then copper minerals crystallize in fractures, and this gives them a porphyritic texture. An example of this mineral is chalcopyrite. Chalcopyrite can be open cast mined, such as in Bingham Canyon in Utah. And these can be smelted, which causes acid rain and deforestation. However, chalcopyrite can also be dissolved and concentrated by weathering. This is called supergene enriched copper. This supergenian-rich copper forms when rainfall infiltrates the ground. And then this leaches to copper sulfides, making copper carbonates precipitate in the oxidizing zone, which is above the water table. This forms minerals such as azurite and malahite. We once had a small incident with azurite. It was quite funny. We didn't know it was malahite. We didn't know it was malahite, and malahite is actually quite poisonous if it's breathed in. And we had a piece of raw malahite, and it said it in Portuguese, which was a bit weird. And it was funny because once we found out, we were quite shocked, but we put it back when we hoped nothing would happen. Luckily, nothing did. It was quite a while ago now, but it was really funny. But anyway, these copper sulfides and other native copper can be precipitated below the water table, making minerals such as chalcocite. And these minerals can be mined, such as in Zimbabwe, which again causes loss of habitat. And then we've got nickel. Nickel forms from ultramafic and mafic magma, which then undergoes crystallization. These magmas make magnesium, nickel, and iron-rich minerals, which can be open-cast mined, such as in Sudbury, Ontario, which is where smelting occurs, and which again causes acid rain and deforestation. An important question that comes up is, where do we get these minerals? For example, where do we get the lithium for our batteries? Actually, lithium originates from Chile, then undergoes processing in America, undergoes checks in Japan, and starts being put in a battery in Korea, and then goes back to America to be finalized in the battery. Then it's transported to near New York, where it's then transported to Europe to be put in an electric car. This means that lithium travels over 50,000 miles before it finds your car. Isn't that crazy? And the question is, why don't we mine it in the UK, for example, or in Europe? Well, actually, we started, and we've been doing a bit better than they have been in Chile, because lithium can be mined in Cornwall and then processed in Wales. Then in Scotland, it undergoes checks, put in the battery in England, and finalized and put in the car in England. This reduces the carbon footprint by over 90%, and that's much more environmentally friendly. We often think that electric cars are very environmentally friendly. A fact they gave us in school was that making the battery of an electric car is equivalent to driving for 10 years with a normal car. And now I understand why, because it really does literally drive for 10 years, really, all the way around the world for 50,000 miles, which is crazy when we could just mine it in Cornwall. So Cornish Lithium is actually starting to do this. So here we can see an old mine in Cornwall, and here are the groundwater, hydrothermal groundwater, and up here is a new mining. And in this new mine, they drill a borehole where they extract the hydrothermal waters and use this hydrothermal waters to extract the lithium from, and they also make hydrothermal energy from it. And I call that effective and efficient. It's a really cool thing which I find that they did. But if we're going to mine, we might as well do it correctly and ethically correct and environmentally friendly. We're not going to go for an old way of mining that wasn't good. So if we're going to mine, we might as well start mining as Cornish Lithium does. So mining can be good. It just depends on where and how we do it. And we don't want to be NIMBYs, which means not in my backyard. So a NIMBY would be somebody who didn't want, for example, this new mining method to be used in Cornwall because either it doesn't look very nice or they just would prefer it because it would be cheaper if it comes from Chile. And it's usually cheaper because it's got lower environmental standards and also lower human standards, because it has lots of people working there who aren't necessarily paid enough, or also the environmental standards aren't too good because there aren't many laws for that. So do we want conventional mining or new mining? I'd say we want new mining, not conventional mining. So we need minerals now more than we did ever before because the population is rising and the demand for minerals and technology is increasing due to this. And we can't have technology without minerals. And COVID has shown us just how important communication is and technology is, because without technology, we wouldn't have communication. And without minerals, we can't have technology. That means that we need minerals. And for example, I wouldn't be able to be doing this today without technology, meaning without minerals. I wouldn't be able to be educated and having my school from home if we wouldn't have these minerals and technology. My dad and my mum wouldn't be able to work without technology. Really, we need a lot of minerals to make all this technology that we need so much. And we need geologists to find these minerals. We also need geologists to find renewable energy technologies, more elements and therefore minerals, and carbon-free, usually local technologies as well. Conventional mining is really quite destructive. We need to find new ways of mining. Really, I guess I wouldn't really know what a new way of mining really is. But some people do, such as probably my teachers, Greg Samways and Neil Ellis. But most of us really don't know what new mining is. Cornish Lithium is an example, but we don't really understand it. But we have to let science do their thing and learn about it and, well, then use it. Once they learn about it, they can use it and make these new mining methods good, instead of the old conventional destructive mining. And we need more eco-friendly ways. And overall, we need geologists to find most of these ways. And geology doesn't equal environmental destruction. For example, we wouldn't be able to find out about something that I'll try that again. We wouldn't be able to find out about a lot of things that lots of people are interested in, like dinosaurs. Lots of children are interested in dinosaurs, for example, and even mass extinctions in the past. And global climate change, prehistoric global climate change. It's very important for us at the moment, as it shows us what the rising CO2 levels can do with the atmosphere, if there's a correlation or not. Really, it's still being debated if there's a correlation or not, but there's some research happening. They've been taking out ice cores, which then have sediment in them, and this sediment contains carbon in it, and the amount of carbon depends on the amount of carbon in the atmosphere. And this shows us how much the climate changed along with the atmosphere, meaning how much carbon there is and how much the climate changed. And many other examples such as this. Fossils are another example that show us what to expect and how climate has changed, causing mass extinctions. And just as I said, we wouldn't know what to expect from CO2. And another greenhouse gas example is methane. And yeah, we need to really research this more and find out what these things can do. We need to make geology more sustainable, ethically correct, and good for our environment instead of destroying it. And we need to be responsible and use our common sense to make everything that's destructive, like old conventional mining, better, like this new mining like Cornish Lithium is doing. And not only is geology important, it's also lots of fun. And it's not funny, like ha ha ha, but it's lots of fun, real fun. And just as an example, here's a bit of my mineral and fossil collection. We've got a lot more, but they didn't all fit on the picture. And some of these things I found myself, like here is some calcite I found. Up here is an igneous rock I found in Tenerife. And I found this pumice in Tenerife too. And there's a lot of other things. Like I could probably go get, there's a shark poo over there. I'll be back. Here, there's some shark poo. We can see we got identified by some geologists. And it's really cool. It's actually called coprolite when it's fossilized. And we got it from Lyme Regis when we went to visit, and it's amazing because you can actually see the difference. And there's also things like that we can just learn about them, find them, which is really fun. And geology isn't bad. It just depends on how and where we do it. We just need to make this better and more local. So I wanted to say thank you for everyone who participated. Firstly, my geology tutor, Dr. Greg Samways, for the resources, guidance, and information, and also materials, and initiating me making this presentation. So thank you. My paleontology teacher, Neil Ellis, for teaching me, guiding me, and supporting me during all of this. And my family, for enabling me to follow my passions and helping and supporting me with everything. And to everyone who participated, Annie, Julia, Simon, Ivan, Aaron, and Sean, for participating and coming here today. Thank you all. And now I guess it's time for me to stop sharing my screen and we can ask questions. So you can all direct your questions to who you want and maybe just wave or something when you have a question. Anybody have any questions?
Yes, I had a quick question for you. Is Cornish Lithium profitable?
I believe it is, but I'm not sure. I think Greg's a pretty good expert on Cornish Lithium, so I'll ask him.
Oh, I was unmuted. Yes, it's in development. It's an interesting story because Cornish Lithium, I think, was actually crowd-funded to begin with, and I think that's an important thing to consider as well. So the whole business started with donations from individuals, and I think they have proved with their initial exploration wells that it is economically viable and that the environmental footprint of the whole process is pretty small. Small drilling rigs and so on, and other benefits as well, of course, of as Nika mentioned, of the geothermal energy as well as the source of lithium. So yes, I think if it's not profitable already, I think all of the financial models are very positive.
Great, thank you. Does anyone else have any questions? Neil?
Got a question, Nika. You obviously this is around the geology of a phone, and you've highlighted, well, the two sides. Number one, the importance of the minerals that go into making the phone, but also on the other side, the environmental impact, which is really interesting to understand. Are you aware of how the phone industry is moving? Are they introducing materials that will use less minerals in order to work, or do you know if that's going to be something they cannot avoid in the future?
Well, I don't know much about it, but I heard that they're doing some research in different countries about how they could use different minerals that are potentially less environmentally destructive to mine, and things like that. Mm-hmm. But in particular, I don't know much about it. Do one of my geology tutors know maybe more?
These are big questions.
Sorry.
It's important that we're talking about. I think Nika is inventing here a whole new subject, which seems to be what, for want of a better word, ethical geology and resource exploration and exploitation. And I think we're only just scratching the surface of what that means for the future. But I mean, I'm not quite sure I'm getting specifically to your question, which is, so what is it that you're really trying to get at here in the question?
But there's a paradox, isn't there, of the importance of minerals and the importance of technology in order to, if you look at from an environmental perspective, and yet it seems at the moment our ability to resource minerals is still having an environmental impact. So it has to be, what comes first? Like the Cornish Lithium example, which is still mining to a degree, and I totally get the NIMBY culture. Or is it, well, actually, the things that we need to do in the future have to have less environmental impact in terms of the way we get those resources? So can we minimize the amount of minerals we need? I mean, even if you look at wind turbines, they're made of metals, so there has to be some process there, of course. So is it ever avoidable, and is there ways that we can produce it that you're aware of? And mine was just purely a knowledge question at a more general level. I don't need to get granular.
No, it's an interesting. It is interesting that. Sorry,
can I have a stab at that one?
Yes, of course you can, Greg. I'll let you, because I'm good like that.
Yeah, I mean, there's a number of issues in here, and the thing I think we have to go right back to in the first instance is, what is the motivation? And so very often the motivation is to get the most competitive and exciting technology the quickest way possible, which very often means using a particular mineral which goes faster and stronger and so on, without any concern at all for what is involved in actually ripping it out of the ground. So that if your motive is to have the biggest, fastest, smartest phone with no consideration at all for the origin of the raw materials, then that's a problem. Another major problem in the industry as well is not just the minerals and the elements that are being used, but the fact that things are still designed to basically fail in 18 months. And that's something we talked about last time, that it's built-in obsolescence, because Apple want you to renew your phone every 18 months.
Yeah.
To the extent that they will even control the distribution of upgrades to your operating system, so that your Apple iPhone 8 is now working more slowly, which forces you to upgrade to a 9, a 10, or 11. So that they're still actively encouraging you to throw stuff away. And this is something Neil mentioned in a previous discussion, that we need a lot more reduction, which you're kind of implying, that we could use different elements and use less of it, and reuse, because an awful lot was still going into ground to, what am I trying to say, landfill. And at the end of the day, one key word that came up from Neil is exploitation, and that's a really ugly word in many ways, because basically it means making profit at the expense of somebody or something else. We're still in that frame of mind. We exploit people and we exploit the environment for profit. And until we fundamentally change that way of thinking, I don't think anything else is likely to change. But just a final word, one little example is that we can go off planet to find these things, Moon, Mars, asteroids, and so on. So I'm a big fan of Elon Musk and Starship. And what's interesting with their developments is that they were going down the path of incredibly sophisticated materials for their rockets. But in the end, they said, let's just use steel. So their rockets are built of 3mm stainless steel, because it's easy. There's lots of it. The planet's full of it. And I was having a discussion with my cousin here. He said, well, when they dump it in the ocean, what will happen? I said, well, it'll rust. And he said, well, that iron oxide, that must be pollution. I said, well, in excess it is, but it's also a nutrient which supports life. Without iron, no life, as I'm sure Ivan will confirm. So it's about striking the balance. There are possibilities, but we need to be creative and imaginative to pursue them, and we have to have the right motive. And at the moment, the motive is still profit. And until that changes, we're always going to be exploiting people and the environment.
Okay. I was going to say, I got a question now for Sean, because he's in IT, and well, Greg mentioned that the Apple, for example, make phones and laptops to be unusable after 18 months. Do you have anything to say about that, and how is that true? And how?
Well, according to news articles that I've read, it is true. And there was a recent class action suit done in America which forced Apple to stop doing that practice, at least on some of the devices. So yeah, it is certainly something which happens. And but having said that, I've had a machine from them since 2012, which is still running very well. So some technology does last, it can last a very long time, almost 10 years. But
I think if you have the capacity to keep it going, so I mean, if you're prepared to take the front off of your computer and swap things out and mend things, but there's two things here. I think one thing is, have you heard of these cafes that have started popping up where you can actually go for tea and cake and mend your technology? So the cafes are run by people who have knowledge and experience of mending technology, which might actually just be your toaster or your hairdryer. But instead of throwing it away, you can take it there and they have all of the tools and the expertise to help you mend it while you have a cup of tea and a piece of cake, which I think is a brilliant thing. Could I ask you to say one other thing as well? You mentioned a class action. What is a class action?
as far as I know, it's a legal term used to say that certain population, a certain group within a population have effectively are taking another entity to court. That's how I understand it. It's an American term. It's not one we have in the UK.
Yeah. I mean, the reason I said that was I wasn't sure whether Nika would know what that was, but I think class actions are generally brought by general members of the public when there isn't perceived to be what's the party who's been aggrieved. I want to say something simpler. The people who have suffered are typically the general public, and nobody is sticking up for them. So it actually requires an organization to get together and crowdfund a class action. So and that I think is happening a lot now in the UK. I think people are doing that, particularly with environmental concerns, because the government is not standing up for those environmental things, and the industry isn't, and so on and so forth. So who does it leave to fight these things? And generally it's individuals who club together and bring a class action, as far as I know.
Yeah.
Which is sad. Society is not doing it. Individuals are doing it.
Yeah, it's very interesting.
I think it brings together. You touched on a couple of things there in those last couple of questions, which seem to be very important, which is the sociological and legal side of what I'm beginning to call ethical geology or eco-friendly geology, basically we're going to have to think about the routes that we use to support the wise use is sometimes used as a phrase, the wise use of resources that we have involving recycling, and this begins to require government policy at national and even international levels, but even down to the specific at sociological levels. We talk about Cornish mining, Cornish Lithium, and it used to be all mined by hand. These wiry little guys going down in small tunnels with hacksaws and hatchets and literally digging out the China clay or whatever it was. And there's limitations to what that can do. But now we have major technologies available to us, which kind of bypasses the need for miners. It's technological ways of doing it, and that can lay off populations. We've already seen the collapse of the mining industry in Britain. Some people might say it's a good thing. In America, the mining industry for coal particularly is increasing after Donald Trump's administration. But is it a good thing for the environment? So we've got to balance what can the nation do through its laws, what can society do to support people who perhaps have been displaced. It's the same argument with fishing. We might say we're overfishing, so we've got to stop fishermen going out to sea catching too many fish. But what are they going to do with their time? How are we going to support those people that can't earn their livelihood anymore? So it's not just about, we have to think at the human angle as well as the conservation environment angle. I suppose that's what I'm getting at. And that means changing law, international thinking, changing everyone's thinking. But this is taking the debate to a whole new level. So if I can ask one just quick question to Nika specifically, which is, what is it about geology that will attract new students to learn it? You mentioned some things in your summary slide. What was it for you, Nika, that really grabbed you about geology that would inspire TAFU members to that geology is something that's really cool. I want to go and study that. What is it? What do you think, Nika?
Well, for me, it was, I guess originally it was fossils and nature, the way how nature evolved from being nothingness almost. I mean,
so the story of life, evolutionary biology, mass extinctions, big extinct beasts.
Yeah.
And I'm with you on that one. It's all right. You can tell I'm passionate about that. But it's so many things, isn't it? It's physics, it's chemistry, it's astrophysics, it's meteors slamming into Earth and creating a moon and killing off the dinosaurs, and volcanic eruptions and earthquakes, and how minerals form and crystals, and the aesthetics. There's so much that we can use, and I think this is what we all need to do as a group. Is to encourage people to study it, because it is beautiful and wonderful and scientific. If you're particularly strong-minded with a legal mind, you want to become a lawyer so you can seek justice and fairness. If you want to cure people from illness and disease, you study to become a doctor. We need to find those reasons. Why should people become a geologist? And it's not necessarily just about grabbing everything we can that the planet offers, but working out how we can reuse, recycle, think about sustainable usage, think about society in which we're grabbing these materials from. So there's some messages that definitely will come out there that we can all use to support you in your quest to get more geologists, which is what we're all starting out at. You're using the phone as an example, but you've got such a powerful opportunity, really.
Yeah, I find that geology can almost satisfy almost everyone because it has bits of everything in it. So anyway, we got 3 people want to ask a question. I think Sean raised his hand first, so you go first.
Oh, I noticed something in your slides, which I didn't know what it was. Is it called pegmatite?
I wanted to ask the same thing.
Yeah, what is it exactly? I saw it briefly, but I wonder if you can talk about it a little more.
Well, as far as I know, it's like I don't know how to really say it. It's like a bunch of magma that stayed underground, so it stayed magma, and it cooled, and then it formed a bunch of crystals of different minerals. And as I said, there was mica and spodumene in it. So those are examples, but there can also be a bunch of other minerals in it as well. I think feldspar is an example. I'm not 100% sure. Maybe Greg on your.
How fast did it cool, Nika?
Slowly, I'm gonna guess.
So how big are the crystals?
Big.
We're talking this big?
No.
Big? Or...
I mean, these crystals can be meters. In big cavities. Neil is rushing off to get a piece of rock with some big crystals in it now. But a pegmatite is essentially a word we use to describe a vein full of big crystals, which are demonstrably much bigger than the surrounding rock. So any vein with big crystals associated with that kind of igneous intrusion is a pegmatite. So I was chasing these around in Brittany on a recent holiday, but the pegmatites I mentioned last time here, they have mica in them, which are 60 centimeters in diameter. So those single crystals are, this big, and you could split them off into individual layers. And in fact, those layers were used as the glass in wood burning stoves before we developed a glass which could withstand the heat. Because what temperature does muscovite precipitate at, Nika, do you remember?
Around 900,000, I think.
I think it's about 900. Yeah, absolutely. So it's about 900 degrees. So that muscovite, which is, I've got some biotite here, which is dark, but muscovite is see-through, and you can split it into layers, and they would cut it into squares and then put it into your wood burning stove because it could stand. Actually, Nika's got a box of mica there, which I sent to her.
It was also used in the Russian space program, of course, because muscovite is called muscovite because
After
it was
Moscow.
found from Moscow, or the Moscow area of Russia, in these big crystal forms, and they used it for the windows in the Soyuz.
I didn't realize they used it in Soyuz as well. Why? Okay.
I believe so. I'd have to Google that just to check it, but.
Yeah, very good. Pegmatite.
Great.
So, I mean, Nika, that's something to remember for next time, is just to say a little bit more about what a pegmatite is on your way past. Because I think it's...
And porphyry as well.
Any other words? Yeah, because Evan wants to know what that is. Any other words in there that's got glossed over?
I think Aaron has a question.
Yeah, you got another word, Aaron?
Oh, not another word, but it's kind of geology is kind of like a specialist subject. We don't really talk about it in school. It's not on the normal curriculum, other than glossed over and talk geography or biology or chemistry a little bit. So my question to Nika is, I think the TAFU is so good and the talk now because it's increasing exposure to it. But do you think there should be more done to teach geology in schools? And like the case study of Cornish Lithium, didn't know anything of that. So when did they start up in Cornwall?
Well, I don't know when they started. I'm sure Greg knows, but I think they should use first part of your question. Yeah, I do think they should do more to teach geology in schools, because I also noticed that most exam centres don't even offer geology as an A level, and most schools don't offer it to be taught at all. So it's also a really important thing that has to just grow, even just exam-wise has to grow, not to mention on it being taught. But it is being taught a bit in schools with geography. There's the physical geography, which is basically just geology. And then there's human geography, which doesn't really have anything to do with geology. So that's why I decided to do geology. Okay, I think Greg has a question.
Just add a couple of things to that. One is there is a major crisis in geology, and this is being discussed a lot in the UK by the geological community. People like Ian Stewart, you may have seen on the TV, is leading sort of campaigns to encourage people to enroll in geology. And the reason, what's happening at the moment is the enrollment for A-level is declining at an alarming rate. Less and less people are signing up for geology. Number of reasons. One is things like Extinction Rebellion and all of the other environmental campaigns who are campaigning against environmental destruction are basically blaming the geologists for global climate change because it's caused by petroleum, which comes from rocks which are caused by geologists. So geologists get the blame for the oil industry, and geologists also get the blame for the environmental destruction when we mine anything, because it was the geologists that found the minerals, therefore the geologists are responsible. So less and less people want to be a geologist. And this is the real paradox, that whatever we do in the near future, we are going to need more minerals. And yet we have, I think the estimates are we need 10% more geologists in the next 20 years than we currently have, but they're declining by 10% per year.
Yeah.
But that's a major problem. That's my local butterfly just come past. But just to address your point directly, Aaron, that they've done a lot of research into how people start doing geology. And very often it's by accident, because they're doing an A-level and they do an A-level in chemistry, physics, and maths, and maybe they want to do 4. So they're looking for another A-level that might be fun. And there used to be an AS level in geology, and that involved a field trip to France. So a lot of people would sign up to the geology because there was a field trip involved, and they got to go to Tenerife or Cyprus or somewhere. So yeah, let's do that. Then when they joined the geology AS level, they suddenly thought, this is great. I didn't know anything about geology. I'm going to give up chemistry and I'm going to do geology as a full-time degree because this is amazing. But the other thing as well is in the core curriculum at secondary level, you've got chemistry, physics, maths, history, geography, but geology has never been a part of that core curriculum. So unless you happen to have a geography teacher who happens to be keen on the geological part, you probably never hear about it. It's pure luck. Now, like Nika, I discovered geology collecting fossils. And then I wanted to become a geologist, but they didn't do geology at my school. So I spoke to my geography teacher when I was Nika's age 13. And I said, I want to do geology. How can I do geology? And he told me that he could teach it, but only if he had 15 students who wanted to do geology. So I think I had 2 months to convince 14 of my friends that geology was amazing. And eventually I got these 14 guys to sign up. And on the back of that, he ran the geology O-level. So that is the way that I did geology at school at Nika's age, because I basically beat my 14 friends into doing geology as well.
We don't think there needs to be a change of emphasis, though, because if you, I mean, sort of relating to your story of how you got into geology, which is like a historic perspective on its role and its formation of everything we have. And then if you look at that in context of the negative side of Extinction Rebellion, and your geologists are responsible for the research that went into ore discovery and all the rest of it, then there needs to be a change of emphasis into what is the relevant role of geography to the world going forwards into the future. Not geography, geology, rather than it being about destruction. What is it going to do to contribute to in a positive way, which will inspire people to want to take it on and not refer to it as such a classical subject?
Yeah, I think that's exactly what the universities are challenged with doing and that's what they're doing big time. And the industry service companies that I work for as well are reinventing themselves as hydrothermal companies or hydrogeological companies, or that they're not just oil industry service companies anymore.
Yeah.
And there's a lot more emphasis on water. Of course, you wouldn't have any groundwater if you didn't have geologists who knew where the groundwater was. So I mean, it's pretty fundamental to everything.
Also, we need to drive innovation to fix all the problems that we have with the world right now, with over-exploitation and use of minerals. And I remember reading an article about the use of graphene in batteries, which makes them last longer, which would mean we need less batteries. So
it sounds like it needs to lobby to be part of STEM subjects. It needs a not a facelift, because that sounds superficial, but it needs a reorientation, because all of those STEM subjects that go towards technological development, which is going to contribute significantly to solving the problems, need the study of minerals, and because we can only use the resources on the planet until Elon Musk has got his act together in 100 years.
Yeah.
It's possible that we have to do a rebranding exercise in a way, which is very popular in modern times. It's like, for those of us that eat meat, I don't know how many of you are meat eaters, it doesn't matter, but it's like no one wants to think about the slaughter of animals and the butchery trade, but they're struggling to get enough butchers now, and it's not a desirable job necessarily. But if you're on the inside, then if you were a butcher and you worked in an abattoir and you were responsible for killing animals and you had a heart, then you would want to do it in the most ethically sensible way to do it. And the only way to change that would be to be in the industry itself. You've got to be the mole on the inside, working out and spreading the best way to deal with the food, and you could think about that in a similar way, a parallel way to geology. Yes, we need all these materials for our mobile phones that are sourced in rocks and ideally from recycled materials wherever that is possible. But we have to think we might be charged with being responsible for the destruction of landscapes and so on. But equally, we're needed, and the best way to improve practice is to be on the inside, working to influence it rather than from the outside trying to impose and enforce.
Yeah. Okay. Well, thank you all. I think Anya has another question. Well, I don't think she had a question yet.
Yeah, it's a quick question for you. I was just thinking, is there different ways that people can get involved in geology without actually studying it? Because not a lot of people want to take it to that kind of level, so they might want to just get involved in it. So in your personal opinion, what do you think?
Well, I know there's a lot of things you can do. Like, for example, you went to visit Lyme Regis recently and you went to try and find some fossils. That's one way of getting involved in geology. And just like spreading how important geology is amongst people, I think that's just important as well. To change how they think about geology is important. As I guess this is really the point of this presentation, to show people that geology is important and there's ways of making it good instead of destructive for the environment. And
can I just
spreading that word is important.
Can I just throw in the Geological Association, for example? So if you want to do something that you're not sure about, you go and find an organization. So the Geological Association is not for people who've necessarily studied geology, but for people who are just interested to find out more. So you can join the association and go with the association on their field trips and find out what's going on.
Mm-hmm.
So I've led Geological Association trips from the UK, which have come and done tours of France, and we just go from one location to the next talking about the geology. It's a social event as well, of course.
Mm-hmm. Yeah, I think Ivan has a question.
I have a question for Nika. I know you do lots of environmentally friendly stuff and recycle and litter picks, but on the issue of phones and mineral use, do you know what's the best way, or is there any other way to recycle phones? If, for example, you buy a phone and if you buy it from O2, you can recycle it by giving it back to O2 and getting a discount on your next one. But if you just have a phone, an old phone, or phone that you bought directly from the manufacturer, what's the best way to get it recycled?
Well, I don't think there's necessarily a best way of doing it, but I know there's a lot of things you can do. Like, we just have a lot of phones in the house right now, and we're trying to look at a way of getting it recycled. So I don't particularly know if there's a good way to get it recycled, but I know there's a lot of recycling companies out there, and probably a lot of them recycle phones as well. But it's probably gonna need a special type of care in recycling phones, as although 6.2 million phones can make all the medals for the Olympic Games, one phone is gonna have like a couple grams at most of everything, if not less than that. So it's going to be really hard to separate it, make sure you get the right thing and put it in the right box. So it might potentially be in the future some sort of recycling company just for recycling phones or something like that, because it'll probably need that type of...
There are. I've just put a link in the chat, I think, which is the 10 best ways to recycle your phone. So I mean, there are companies out there that are specializing in doing that kind of thing. So I think we for the next time we present this, I think it'd be a good idea, as even suggesting, to have some examples that we can hand out to people.
Yeah, that's useful.
Absolutely. Yeah. Same with like printer ink cartridges as well. As many companies, you can send your old printer ink cartridges because they've got little gold-plated connectors to operate the ink cartridges and things like that. I always use the refilled ones, and it's small steps that are going to make a difference.
Also
Little
talking about printers, there's this new type of printer that this is not new, but relatively new. In the last couple of years, there's been this slightly newer type of printer that it's got completely liquid. Obviously, all of them are liquids, but little bottles of it, and they last forever. They last for like 3 years instead of like 1 or 2
Wow.
months. I think
That's
Sean,
the way forward. Yeah, finding new answers to the same, the same technological problems, finding new materials that are more efficient, save unnecessary exploitation of potentially toxic materials getting into the environment. All this is good. So
this comes back, just one point, I've got to shoot now because I've got a 2 o'clock, but just comes back to Simon's point earlier on, is why do we use the technologies that we currently use? And it's typically because they're the cheapest and the most profitable. And as I said earlier on, as long as the motive for these things is profit and wealth generation for the few, then there isn't a great deal of motivation to change it, unless everybody votes with their feet and refuses to buy the next Apple iPhone until they create one that lasts 10 years. But they're never going to do that because their business is based on buying a new one every 18 months. That's how they make the money.
on that topic, that's basically TAFU's point, to get everybody, individuals, to make differences in their everyday lives, like buying this other type of ink. That's what we do, and that lasts much longer. And there's many other things that we can do to like that just make it better. And if we start buying more of that type of stuff instead of that type of stuff, then the bad type of stuff is going to diminish, and a lot more things are going to get better if we start buying better stuff.
Can I ask, just before I go again, does anybody use the True Earth? They're like pieces of paper that you use in the washing machines. Anybody started using those?
No.
The argument for those is that you go to the supermarket and you buy a great big container full of washing liquid for your clothes and your washing machine. And like 90% of that is water that you don't need. And it's in a plastic bottle that you don't need. So what this company called True Earth, I think it is, they now have produced these things which are like a piece of card about this size, which you rip off a strip and throw it in the washing machine, and it dissolves, and that does your washing. You don't need a plastic bottle, and you don't need lots of fluid full of chemicals. All of the washing material is in that kind of like a piece of rice paper. So it's another one of those things. It just makes perfect sense. It takes a lot less space. There's a lot less plastic being recycled or going into landfill and so on. So yeah, absolutely. Small steps, but only if people know about them.
Yeah, thank you. Gonna take a note of that. So it's really all about
Can I say, brilliant. Well done, Nika. Absolutely great. But I've got to run because I've got a 2 o'clock. So I'm just going to drop out now and leave you guys chatting.
Thank you. Bye.
Thank you. Bye-bye for now.
I think Sean has a question.
And one, Greg has actually just reminded me of something which we've only just started using, something called solid shampoo, dry shampoo actually. So rather than having it's basically a bar of soap, but they've got rid of all of the water inside of the shampoo and just reduced it to a bar of soap that you can use instead. So then that's always distributed in a paper packaging. So no plastic being used there whatsoever, which is quite nice. But one thing I just thought of was that it's good to say that geology, we should use geology in such a way to make things more environmentally friendly and what have you. But I think maybe it's good to appreciate how good the mobile phone is, for example, and how good a technology it is. The Royal Institute did a lecture a while back which demonstrated this, which is effectively asked a question or demonstrated what it does. What does your mobile phone do? It replaces newspapers, it replaces televisions, it replaces pretty much all of the wiring for telephones potentially. It replaces your telephone at home. It replaces, they listed like 30 odd different appliances which we would otherwise have bought in order to facilitate the way that we live. But what we have developed is something which is very small, takes up very few resources compared to what would have been taken up had we not invented it. So even though we are using those sort of precious metals and whatever, if we were not using those, but we're still producing and using same products which we were before. Now we've got rid of cathode ray tubes, for example, and LCD screens. The device itself has actually been, even though we say that people are taking profits and whatever, yeah, they're taking profits, but compared to all the other material that we would have used otherwise, this is a much more environmentally friendly product, in my opinion.
It's also massively efficient at distributing information in order to educate people on the things they need to be doing, rather than having to go to town hall meetings or libraries. Of course, it does disinformation as well, but there's a cure for that one day. It's called a blockchain.
Yeah, indeed.
I'd like to add to that, because it's also a good way to, be used in science, because everyone's got a phone. And just the other day we did Rocky Shore Intertidal survey at one of the beaches here, and instead of using a pen and paper and other single-use materials to record the data, we just used a phone and an app that was developed for that purpose. And it was easy. Every person had a phone and recorded the quadrats, took pictures, and then uploaded the information to a server later.
Yeah.
There are lots of advantages.
Yeah, I think that's very true. But I also think that we shouldn't stop as soon as we get something slightly better. We're just getting happy if something's better, but not, I mean, nothing's going to be perfect, but not at the best that we can at a single point. Like now we can do better than we're doing, but we're not doing it. There's a lot of things that we can do. Like something, like there's a catalyst that can turn carbon dioxide into fuel without creating methane, which has recently been discovered. We're not going to use that though for some reason. It just doesn't happen. There's a lot of things like that. Like there's bacteria that eats plastic as well. That hasn't been used. So there's things that we just have to use, even though we have them, we're not being used because there's no will for it. Just have to show, explore, and have the will to do it.
There also needs to be a lot more funding for innovation to make any progress in using the new discoveries efficiently and effectively.
Yeah.
And I think we have to remove the northern or western hemisphere bias as well. We probably, I don't know about you, I've got about 3 old mobile phones in my drawer and I haven't recycled them yet, but I'm not going to throw them in the dustbin and have them thrown away. I will recycle them. When I get rid of my obsessive compulsive disorder about worrying whether I'm losing any data or pictures or anything. But yeah, we've got challenges to use those old phones to send to people who are impoverished. If it is such a valuable tool for everyone now, then we don't want to disadvantage people in what we used to call third world, or we now call developing countries, who don't have access to the technology. It's got to be global. Because if we have plans to modify our behavior by the way that we mine for the minerals that we need, or the way that we recycle materials, or the way that we use consumables like dishwasher tablets or whatever it might be, we've got to be able to share that message with everyone on the planet, because there's no planet B. We haven't got a second planet we can just suddenly pack our bags and go to. We've got to look after this one. And I think that's a key message for me, is we've got enough. It's like there's probably something like about the nuclear weapon capability of mankind in the Western world is enough to, so in Russia, America and Britain and France, Germany, all the collective countries, we could probably destroy the Earth's surface about 90 times over. And once is enough. And we don't need that capability. Why are we investing so much money in weaponry when we could be thinking about just educating everyone in the planet to use our resources wisely, including radioactive minerals, which we also mine for power. So there's lots of things we need to do: solar, wind, nuclear. No one likes talking about nuclear power, but it is actually quite a clean form of energy, relatively speaking. so there's an awful lot to do, and geologists can help. And this is the sort of message. These are the messages that I'm sure Nika is trying to get across. You did a great job, by the way, before I disappear as well, like Greg, to say well done. That was a great presentation. It made me think about the carbon imprint for transporting all of those materials from one side of the world to the other side and back again twice. We could have drilled a tunnel through the center of the earth and got all the iron and nickel by the time, it'd be a shorter route, wouldn't it, for some of that? It's incredible that economics works in such a way that that's why it happens that way. And that's why there are so many sociological elements to the whole argument about exploitation of cheap labor in other countries, and this Western centric thinking that we've got to get over. But well done. I really enjoyed it, and I think it's really getting some messages home, that presentation. So I think it's a useful tool to push more widely.
Thank you.
Well done.
Thank you. I guess you were getting at exactly the point, actually. We should all work together, all the sciences, or everybody should work together, putting our heads together and making things work, if you see what I mean. And yeah, that's exactly the point. I also really liked how you said about giving people in the, I forgot how you called it.
Developing world. I think we call it developing world is what we say. People who are disadvantaged, don't have technology that we have on our doorsteps. I can go to about 10 mobile phone shops within 20 miles if I wanted to.
Yeah, and actually the other day we were using an old hard drive to find some pictures, and it was so slow. Then I realized that, I guess 20 years ago, before I was born, these people would really like it, and it was probably really fast then, and people in developing countries would probably think the same.
Yeah, I've given away old computers to community centres, disadvantaged people. Yeah, this is the sort of thing we should be doing.
Yeah. Does anyone have any other questions? No? Nobody? Any comments maybe then?
Nika, how old are you? Do you say you're 13 or you're 13? Yeah, I mean, and is English your first language? Or it is your first? Sorry, I wasn't quite sure, because you live obviously in Croatia or somewhere around there. Where do you live?
Yeah, France and Croatia.
Okay, so I mean, the point is, English is your first language, but you speak other languages. So it was very, very good in that respect and very thought provoking. One suggestion, which is just personal to me, is you're showing lots of images, which is nice, but because you didn't delete the images behind the image you were talking about, I found it difficult to follow sometimes the one you were talking about. So it's just as you move on in your visual presentation to introduce a new image, get rid of the ones behind. That's
okay.
Then I can focus on what you're talking about, because for someone like me who doesn't know much about geology, a lot of rocks look the same, but they have a different story. So make them the star of your screen.
Thank you.
Okay.
So I guess that's it then.
Well, yeah. Thank you very much, Nika.
Thank you.
Good luck with future developments with all of that. And I'll look forward to speaking to you on Tuesday for some more fossils.
Thank you.
Okay.
So, thank you everyone for joining us today. And well, yeah, thank you for participating. Thank you for watching. And as a final note, I just wanted to say that geology is nature. Biology is nature, chemistry is nature, physics is nature, and so is geology. Rocks are part of nature. If we got rid of humans, we would see rocks and wildlife. So there's life and rocks living in a way. So what I'm trying to say is that rocks are part of nature, and rocks aren't artificial or wrong by themselves. It's just how we use rocks that are wrong. So we should start using rocks in a better way and more environmentally correct and safer, and also ethically correct. So yeah, thank you all, and remember to stay responsible and be responsible and use your common sense to do the right thing. And thank you all.
Thank you very much.
Nika. Thank you.
Thank
Goodbye.
you.
Bye.